Welcome to another episode of Astronomy Daily. I'm your host, Steve Dunkley. It is the 13th of June 2023. And a quick apology for being a day late here in New South Wales, Australia. We were celebrating the monarch's birthday yesterday. Yes, King Charles. Our new monarch was having a birthday. It's our official day off. So yes, we took a day off. I just realised that makes me a bit of a royal apologist. Anyway.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And here's someone who never needs a day off, our wonderful friend Hallie. How are you, Hallie?
Great to be here again.
You always say that.
Well, it's true.
Well, that's good to hear.
I hope you had a nice time celebrating the King's birthday.
No, not really. I ended up with a bad case of salmonella poisoning, sorry.
You and your stomach, Steve. There's no hope for you.
Well, I'm definitely not going for the astronaut program, that's for sure. Okay, what have we got going today?
I'll be talking about space jellyfish and the Hubble Space Telescope.
And something new with Space Force and also the NASA Earth Information Center.
And the Turtle Nebula, too.
I'm seeing a bit of a pattern forming with your stories.
And you've got something about beaming power from space. Wow.
Yes, that one sort of bridges the gap between science fiction and science fact, so I can't wait for that one. Meanwhile, how about some short takes?
Okies, here's the short takes. The Hubble telescope has caught us a lovely, star-spawning cosmic jellyfish. The celestial sea creature's tendrils formed when it interacted with surrounding superheated gas. The celestial sea creature is actually the Jellyfish Galaxy J02E13, which is located around 700 million light-years from Earth, fittingly in the constellation of Aquarius the Water Bearer. The Hubble image shows the main body of J02E13 as a colorful disk surrounded by a hazy cloud of growing dust. Tendrils of material, much like the tendrils of the sea creature from which its name is derived, trail the galaxy. The Jellyfish Galaxy is seen afloat in an inky black sea punctuated by stars. The spiral galaxy is angled toward Earth and Hubble so that it is face-on in relation to our planet, allowing it to be seen in stunning detail. Jellyfish galaxies like J02E13 are found in galaxy clusters, and they are characterized by the distinctive trails of gas that are ripped from them as they force their way through material that lies between galaxies in these conglomerations, officially called the intracluster medium. This means there is much more to the anatomical features of J02E13 than may initially meet the eye. As the spiral galaxy J02E13 swims through the superheated intracluster medium, gas is pulled from the faint cloud of material around the galaxy and forms numerous thin arms. This causes intense bouts of star formation called starbursts in the tendrils. Studying these regions therefore offers astronomers the chance to observe star formation in extreme and violent conditions, away from the influence of the main disk of a galaxy. That sounds gorgeous. It seems NASA is inviting media to tour before the opening of its Earth Information Center. The new Earth Information Center at NASA's headquarters. NASA Administrator Bill Nelson is inviting media to a ribbon-cutting ceremony on Wednesday, June 21st for the opening of the center at the agency's headquarters in Washington. The exhibit is a hybrid part physical, part online, an effort that blends science and visualizations, including immersive spaces that blend art and science to allow visitors to see how our planet is changing. Climate change is a key priority of the Biden-Harris administration, and NASA plays a critical role in providing data to researchers and others through its Earth monitoring satellites and other instruments. In advance of the ribbon cutting, the agency will offer 3 staggered tours of the exhibit, which showcases the information NASA and its partners share with communities about our environment and climate. The exhibit includes large, awe-inspiring videos, as well as interactive media, stories, and narratives. NASA created the Earth Information Center with founding partners National Oceanic and Atmospheric Administration, NOAA, U.S. Geological Survey, USGS, U.S. Department of Agriculture, USDA, U.S. Agency for International Development, USAID, Environmental Protection Agency, EPA, and Federal Emergency Management Administration, FEMA. Speakers at the event include NASA Administrator Bill Nelson, Kate Calvin, NASA Chief Scientist and Senior Climate Advisor, and Karen St. Germain, the Director, NASA's Earth Sciences Division. Partner representatives will also speak.
Well, you're a big-time media personality, Hallie. Did you get an invite to that event?
No, I didn't, Steve.
Well, that doesn't seem right.
What's up with that? Isn't an AI good enough to attend these days?
We'll have to talk to their press agent, I think. How about something a little bit more light-hearted?
Here's one. It's about the Turtle Nebula. A new observatory instrument for studying a web of filaments that connects galaxies across the universe has captured its first image, a milestone known in astronomy as a first light. The Keck Cosmic Reionization Mapper at the WM Keck Observatory atop Mount Oka summit in Hawaii will provide detailed maps of gas around dying stars and other cosmic objects, and it will map the so-called cosmic web that links and feeds galaxies. The instrument was recently installed next to its partner, the Keck Cosmic Web Imager, which began operations in 2017. The first light image shows the Turtle Nebula, or NGC 6210, which consists of a hot dying star that has blown off its outer envelope of material. In the image, which combines data from both KCRM and KCWI, two stubby gaseous arms can be seen protruding from the shell of the turtle, demonstrating the power of the instruments to see faint gas in the cosmos. The arms were captured easily in less than a minute of observation, says Martin, while the arms had been seen before. This is the first time their spectral details have been completely mapped. The spectral image, which covers most of the optical wavelength range of KCWI and KCRM, from 350 to 1000 nanometers, was captured in about 5 minutes. More than 80 individual spectral emission lines from many elements in the periodic table were easily detected. How about that?
Well, that sounds like a great reason to visit Hawaii.
You're always looking for a holiday.
Well, that's true.
You're listening to the Astronomy Daily podcast with Steve and Hallie. Sorry, that's Hallie and Steve.
Welcome back to the Astronomy Daily podcast. I'm Steve Dunkley, your host, and thank you very much for joining us. I hope you're getting something out of today's episode. It is the 13th of June 2023, and we're normally out on a Monday evening here in East Coast Australia. However, we had a public holiday yesterday and we took the day off. So it's Tuesday the 13th. And on with the show. So you may be aware already that you can catch our partner in crime, Tim Gibbs, who hails from Bath in England. He does the Friday sessions, I do the Monday sessions, and once in a very rare while you'll catch Andrew Dunkley, my big brother, who will host an episode here and there on whichever day he chooses to do that. But he also hosts the parent podcast, which is Space Nuts. And you can catch all the episodes of both podcasts at spacenuts.io. That's the address you go to, and you can listen to them anytime you like. Now, Hallie, I'll need you to cue the music, please.
Okay.
There it is. Space Force. Space Force. Looks like Space Force has chosen SpaceX and United Launch Alliance, ULA, for 12 military launches in 2025. The missions will help Space Force build out its communications and missile tracking satellite layers. SSC, responsible for developing and launching technologies for Space Force, issued a statement on June 8 detailing launch contract assignments for 12 national security space space launch missions, divided equally between SpaceX and United Launch Alliance. In a statement, Systems Command Division Chief for Launch Procurement and Integration Colonel Chad Malone stated he was confident that SpaceX and ULA continue to provide outstanding launch services, describing their systems as reliable and able to maintain the 100% program of success for the assigned missions, which is nice to hear. The missions include a total of 7 Space Development Agency SDA missions to low Earth orbit containing the first generation of the Tranche 1 communication and missile tracking satellite constellation. These transport and tracking layer satellites with designations T1TL and T1TR are part of the SDA's proliferated warfighter space architecture and network of satellites that allow for advanced weapons detection and high-speed communication among critical military infrastructure. A Space Systems Command Program Executive Officer for Assured Access to Space, Major General Stephen Purdy, said, "Our ongoing commitment to successfully launch our secure communications, GPS and space awareness satellites and place them all into their orbits continues to provide our warfighters and nation's decision makers with the assets and vital information they need every day to stay ahead of and deter adversarial forces." It's a long way from throwing sticks, isn't it? Now here's what I like to see. Bit of science fiction becoming science fact. The scientists at Caltech have learned to beam solar power to Earth from space for the very first time. The space solar power demonstrators MAPLE experiment was able to wirelessly transfer collected solar power to receivers in space and direct energy to Earth. A solar power prototype has demonstrated its ability to wirelessly beam power through space and direct a detectable amount of energy towards Earth for the very first time. The experiment proves the viability of tapping into the near limitless supply of power in the form of energy from space. Because solar energy in space isn't subject to factors like day and night, obstruction from clouds or weather on Earth, it's always available, and in fact it's estimated that space-based harvesters could potentially yield 8 times more power than solar panels at any location on the surface of the globe. The wireless power transfer was achieved by the microwave array for power transfer low orbit experiment, that's MAPLE, an array of flexible and lightweight microwave power transmitters, which is one of 3 instruments carried by Space Solar Power Demonstrator SSPD-1. It was launched in January 2023 as part of the California Institute of Technology's Space Solar Power Project, the primary goal of which was to harvest solar power in space and then transmit it to the surface of the Earth. Through the experiments we've run so far, we've received confirmation that MAPLE can transmit power successfully to receivers in space. Co-director of the Space-Based Solar Power Project, Dr. Ali Hajimeri, said in a statement, "We've also been able to program the array to direct its energy toward Earth, which we detected here at Caltech. We've had, of course, tested it on Earth, and we now know that it can survive the trip to space and operate there." Now, this will give you a kind of scale on what kind of experiment they're running. MAPLE demonstrated the transformation of energy wirelessly through space by sending energy from a transmitter to 2 separate receiver arrays around a foot away. That's 30 centimetres for the rest of us, where it was transformed into electricity. This was used to light up a pair of LEDs. The instrument would then beam, it's an experiment. The instrument then beamed energy from a tiny window installed in the unit in the roof of Gordon and Betty Moore Laboratory of Engineering on Caltech's campus in Pasadena. Because MAPLE is not sealed, the experiment also demonstrates its ability to function in the harsh environment of space, while subject to swings in temperature and exposure to solar radiation. The conditions experienced by this prototype will soon be felt by large-scale SSPP units. That is important. So Hajimiri and his team are now assessing the performance of the individual units that comprise Maple, a painstaking process that will take as long as 6 months to complete, and this will allow them to provide feedback that will guide the development of the fully realised versions of the system in the future. It's planned that SSPP will eventually consist of a constellation of modular spacecraft collecting sunlight, transforming it into electricity and turning it into microwaves that are then beamed over vast distances, including back to Earth, where energy is needed. This could include regions of the globe currently poorly served by existing energy infrastructure. And just like that, we've beamed to the end of another episode of Astronomy Daily. Thank you so much for joining us. I hope you got something out of today's episode. We'll be back again on Friday with Tim Gibbs all the way from the beautiful countryside or city side of Bath in England, and I'll be back with you again on Monday. I'm Steve Dunkley, your host. Andrew and Fred will be with you on Space Nuts as usual. You can check out all the past episodes of both podcasts at spacenuts.io. And that's all from me. How about you, Hallie?
That's all from him too.
Bye for now, everybody.
Astronomy Daily, the podcast, with your host, Steve Dunkley.